All right. So in class, we had to do this practice question, and I recorded a video of me doing it together with you. That way, if you were confused during class, you can kind of see my thought process. So using the sum rule, we know that we can do each one of them separately, right? Individually and separately. So why don't we just start with this one? We want to take the derivative of this, which is log 3 2x squared. Okay. Well, when we want to take derivatives with respect to log, the first thing you want to ask yourself is if the derivative is in terms of natural log, because we only really know how to take derivatives with respect to natural log. So, first thing, notice it's not based on natural log because that's not an e. So, if it's not natural log, we want to convert it into natural log. So this is equivalent to the derivative of natural log 2x squared to natural log of 3. Okay. Once we have it in terms of natural log, which rule do we know? We know that if we want to take the derivative of the natural log with respect to x, then it's just 1 over x. So if we can put it into this form, that'll be really great. Okay. So obviously, we currently don't have this form. What we could do is do a substitution, meaning let's let y, right? Let's do y is equal to 2x squared. So now what we have created is a function of y, where we have 1 over log of 3 log of y. Well, given a function of y, finding the derivative is pretty easy. So df dy, the derivative, well, this is a constant, so nothing changes here. It's constant. And this part is what we learned previously. It's just 1 over y. So now we found df dy. But what we really want is df dx. But we can achieve df dx by multiplying df dy by dy dx, because the y terms cancel out. Okay? And now, if we want to find dy dx, we simply take the derivative. Now we view y as the function with the variable x. We take the derivative of this. The derivative dy dx is equal to 4x using the power rule. So now, like I said, if you use df dy times dy dx, you're going to get df dx, because these terms cancel out. So df dy is 1 over log of 3 times 1 over y, and then the y dx is equal to 4x. So what was y? Y was right here. So I'm going to replace that with 2x squared. This gives us 1 over log of 3 2 over x. Okay? So this is how I get the derivative of the first term. In the next page, I actually show you the solution. So you can see that the solution is indeed what I just wrote. Okay? They're the same. So now that we got the first term, let's work on the next term together. The next term, okay? Okay, so now let's look at this term. This term, we can divide this into two separate terms, which is 2x. We're going to call this function a, and e to the 3x. I'm going to call this function b. So now, if we want to find the derivative of this, we can use the product rule. The product rule is the derivative of two functions, a and b, is equal to the derivative of a times b plus a times the derivative of b. Okay? So this means that if we find the derivative of a and the derivative of b, then it's pretty easy. We just plug it into the formula. A prime is equal to 2, right? If we find a derivative here. Now, b prime here is equal to e2, well, we don't know how to take this directly. What we can do is write it as e to the y, where y is equal to 3x. So the derivative of this is easy, right? dy. So it's just e to the y. And now this is equal to df dy. We can do the same thing, dy dx, which equals to 3. We multiply them together, which is the final derivative, df dx, is equal to 3 times e to the 3x. So 3 times e to the 3x. Okay, so now we simply follow this equation and plug it in. So the derivative is 2, right, a prime times b, which is e to the 3x, and then plus a, which is 2x, times b prime, which is times 3e to the 3x. So altogether, we have 2e to the 3x plus 6x e to the 3x. And there's a minus sign here. So minus. And this is our residual term. You can see how you have 2e to the 3x here and 6x 3x. There we go. So the solution, this is how I was able to get the solution. There's one last term, which is a constant. And using the constant rule, we know that this is just 0. Okay? So this is how you can solve this particular example. Okay? Hopefully that helps. I'll see you in class.